Hello, this is Ron Castle with Sunshine Works, sunshineworks.com. This video is a demonstration of how to wire a relay. In this case, we're using a 30 amp, 40 amp rated automotive relay. Looks like a little squid. A lot of folks who don't know much about wiring low voltage and off-grid solar applications make them think it's worse than a squid. I think I'll change that. We're going to use an automotive relay today, rated for 30 amps. What is a relay? A relay is a switch that switches a switch. And there are lots of good reasons, especially in low voltage applications like we typically encounter in off-grid solar applications, for using a relay. One of them is to allow higher amperage circuits to operate on lower voltage switches. An example would be in the case of this small toggle switch. It's rated for 16 amps. We have a low voltage thermostat switch which is rated for 12 amps. We have a pressure switch which is used commonly in applications with simple pump and other low voltage water pumps that operates at a maximum current of 15 amps. And then we have a photo eye switch which is used in lighting applications, typically dusk to dawn type igniting of a lighting circuit, so that it happens automatically. What we have here is a small, I missed this switch, sorry, a 8 amp mercury free, this is an 8 amp mercury free float switch, which is used in pump up or pump down applications for water pumps. In this case, this is a pump up switch, off when full. There is an opposing switch which is used to turn the pump off when the water in a reservoir reaches its lower limits so that the pump does not run dry. And what we have here is a small 12 volt battery. We're using a terminal strip to make the wiring easier to control and to make good secure connections without having to use wire nuts or crimps, etc. We have a small toggle switch, we have our relay body, and we have the load, which is this LED light bulb. The load could be any number of things. The load could be a pump motor for water pumping. The load could be, well, I'll come back to that. One of the advantages of using a relay is that let's stop that one also. In the relay body, what we have is a total of 5 wires, and there is an electromagnetic coil, which is the switch in the relay. When the circuit is energized, the coil either opens or closes. When we energize the relay coil, it closes, creating a circuit. And in the case of this particular relay, the blue wire is the common wire. When the switch is normally opened, this red wire is energized. When the relay is normally closed, then the yellow wire is energized. So to explain the circuit, what we have here is battery positive, battery negative. We have battery positive here, which is traveling through the blue wire, which goes through the relay. We also are using battery positive to energize the white wire, which is the positive wire that goes to the relay coil to provide energy for the coil when we actuate the switch. We have the yellow wire back from the relay, which completes the circuit to the load. The positive for the load is going out on this side of the terminal switch. And we have a jumper from the battery negative to the load negative so that we can complete the circuit. When we actuate the switch, the light comes on, and you may be able to hear, if I'm quiet, a little clicking sound of the coil in the switch energizing. As I mentioned before, when the switch is closed and the yellow wire from the relay is not making a circuit, this wire is hot. So there would be two ways to use the switch. One would be to energize the coil to turn the load off. The other would be to energize the coil to turn the load on. The relay can be used either way. The least energy consumption would be the way that we have wired it, where there is no energy being drawn from the relay in the off state for the load. Let's go back through this one more time. Hello, this is Ron Castle with SunshineWorks, sunshineworks.com. Today we are going to make this video to show how to wire a low voltage relay, relays are commonly used in solar applications for situations where we need to provide switching from a considerable distance and we don't want to use great big wire. The other alternative is in situations where the load of the circuit for the load, uses more energy than what small switches are able to handle. So the relay is rated for 30 amps, whereas this little toggle switch is rated for 16 amps. This thermostatically actuated switch is rated for 10 amps. The